number 1, Innovation Project, mission number 7, Robot Dance, and mission number 2, Step Counter, the code is a bit simpler without an addition of sensors. So the first step is for you to open up Lego Mindstorm's EV3 software, and you should get onto this page. Now, if you click File, there should be options to open project, open a new project, or open a recent. We are going to open up a new project, and you're going to choose Program. And it should start loading a new screen, which is this one. This is the home page where you're going to be coding all your code. So as you can see, you have a Start button here, which all of the code should be attached to when we start attaching the code. For mission number 1, Innovation Project, mission number 7, Robot Dance, and mission number 2, Step Counter, the code that you'll mainly be using is the Move Steering block from the green section below. So if you go to the green section and go to the third block in, there should be a block which if you hover over it should say Move Steering. You're going to click, hold, and drag and attach this block to the first block that should already be in your code. So this block is the basic block that'll have your robot moving. You can change the direction, the speed, and how long of a distance you want your robot to move. In order to change the direction, you're going to change the number inside this first category that has the arrow above. If you notice, if I change it to 50, the arrow gets bent, which means it's now going to turn. And if I wanted to go the opposite direction, I can just put a minus sign and then the same number. So if I keep it 0, the robot's going to go completely straight. Now the next section is speed or power. So the higher the power, so if I do 100, which is the maximum for this code, the faster the robot will go. So in some of the missions, you might need a slower robot in order to make sure that you complete the mission as accurately as possible. So you can do like 10 or 20, whatever number you put in here is going to change the speed of the robot. Now, you do have to return back to the base at some point. And so usually how you go backwards if you don't want to turn your robot is you just make this number in the speed section, whatever it would be. So say it's like 50, you make that a negative number. So a minus sign and then 50. As you can see, when you did this, the arrow reversed, and so now it's pointing downwards. This signifies that this block of code is going to go backwards, or the robot is going to go backwards for this block of code. So if I just put it back to normal. Now the last section is number of rotations. So a rotation in terms of Lego Mindstorm is one full turn of the wheel of the robot. So one rotation is one full turn of the wheel. So this is basically distance. How long do you want the robot to drive for? So for our block, we have it driving forward. So it's going to go forward for one full rotation of the wheel. Now you can actually measure how much of a distance one full rotation is, and it does take some mathematics, but for a lot of teams, they do just kind of take the robot and make a guesstimate of the distance and then do a trial and error system. So, and you can always just change the distance by clicking on this little section and then putting whatever number of rotations you need in there. If you do not want to use number of rotations, you can always come over here. If you click this, you should see there's certain settings that you can have for the move steering block. You should see that there is something for on for degrees and on for seconds. If you choose on for seconds, you can change how long the robot drives forward or does whatever direction that you had it doing for a certain amount of time instead of number of rotations. And the same can be for degrees. So instead of time or number of rotations, you can have it go for a certain amount of degrees. So for the first mission, mission number 1, Innovation Project, this code would be able to complete that mission, or at least this would be the first part of your code. You could just change the number of rotations to whatever you would need, and then add another block and do the same amount of rotations you would need to go back, sorry, that would just be 5. And then you would just change the speed from 50 to -50 or whatever speed that you had. So this would be enough time for you to go place your object where you need it and then be able to come back. Okay, so the next mission we will be learning how to code is the step counter mission, which is mission number 2. So with the step counter mission, the first thing we need to do is we need to approach the step counter mission. So we're going to come to the green section and get the third block in, which is our basic move steering block. You're going to click, hold, drag, and attach this to this first block. So we're going to adjust some of these settings to what we need in order to get to the mission. So we're going to change number of rotations from 1 to 4. So this should get us to the step counter mission. Now we need to add a loop because the next steps for this mission is for a robot to continuously hit the mission in order for us to get that little piece where we need it. So we're going to come into this orange section and add a loop, which should be the third block in. We're going to click, hold, drag, and attach it. Now we're going to change this unlimited to count. So what is a loop? Well, the loop is a block of code that allows us to repeat certain actions that we want for a certain amount of time or for forever, which is what we had before we changed it to count. So this is important for this mission because if you noticed in the video, we had our robot hitting the mission a few times in order to get it to the position we needed it in. So what we're going to do is we're going to code the actual hitting part inside this loop. So what we're going to do is we're going to go over to the green section. You're going to get the move steering block and you're going to attach it inside the loop. So now the robot is going forward a little bit more and then we want it to go backwards. So we're going to come over here to the move steering and attach another one, but this one has to go backwards. So we're going to change this from 50 to -50 and we don't want to go back too much, right? So what we're going to do is we're going to change the number of rotations from 1 to 0.3. Okay, and we're going to change this from count to time. So now we have that the loop is going to continue on for 5 seconds, but we actually need to change it to 15 seconds. Okay, after we finish with this loop, we are going to add a move steering block again to the end of the loop. And we're going to have it drive back to base. So we're going to have it be -50. And we're going to change this to 5. And that is the code for the step counter mission or mission 2. For those of you who would like to use a color sensor in your code for some of your missions, in this session we will be learning how to use a color sensor. So on my robot, I'm using 2 color sensors. However, if you have 1 color sensor, this code will work as well.
Hello, my name is Saba Mendoza and I'm in 8th grade. For the mission I did was mission 13, weight machine. For this mission, originally when we programmed it, we were using the color sensor following the black line to go it. In the end, we decided to change the mission a bit, so it went all the way across the black line, moved backwards to straighten itself out by hitting the back wall, and then it would move forward and try to hit the weight machine before trying to go back home. It took some time with editing with the point where it was supposed to hit, including we had to edit our fixture itself so that we could get repetitive results of it hitting the weight machine. In the end, we were able to do this with some other minor problems which we fixed.
Say you wanted to follow the black line to the treadmill mission. In this session, we will be going over the code that would help us complete this. We are going to begin our code by placing a move steering block from the green section. This is so that the robot can get closer to the thick black line. After this, we will be adding 4 more blocks of code. The first block we'll be adding is a loop. So we're going to go to the orange section and attach the middle block, which says loop, to the move steering block we have already placed. We're going to edit the loop so where it's not unlimited, but instead it is set on time. So we went to where it said unlimited and we clicked time. So instead of using 5, we can use a bigger number like 38. And the reason why we're using a bigger number than 5 is because we want the color sensor to be working long enough for the robot to follow the complete black line from one end of the map to the other end of the map. So depending where you start on your base and how far down the line you want, this time can change, but we're going to put a larger number just for right now. So now we're going to add the rest of the blocks inside the loop. So we're going to add our color sensor block, which we're going to find in the yellow section, which is the sensor section. The color sensor block should be the second block in, and we're just going to click, drag, and attach this inside the loop. Now for our color sensor, we actually want it in the reflective mode. What we're going to do is we're going to come over here where it says measure color. We're going to click on it, select measure, and then go down to measure reflected light intensity. So now we have adjusted our color sensor. After making some adjustments to our color sensor, we also want to check up here where it says number 3 and make sure that we have in our code the right port that we have the color sensor attached to in the robot. If the port is incorrect in the code, you can just click it here and then choose whichever number port that you have the color sensor on your robot connected to. So the next block that we're going to use is the math operation block. So we're going to go to the red section, which is our data operations tab, and we're going to click the 5th block in, which says math. We're going to click, hold, drag, and attach it up after the color sensor. Now we have to make some adjustments to this block as well. So we have to come over to where it says add and the plus sign. We're going to click and we're going to choose advanced, which should be ADV. And your block should have expanded and you should have gotten a section here where you can add an equation. So this is the next section that we're going to actually adjust. So if you click right here, you should be able to type in whatever equation that you want. So we're going to delete the equation that it's defaulted to, and we're going to add our own equation for the color sensor, which is going to be parentheses, A minus B, another parentheses, and then you're going to do the multiplication sign, which should be your just shift 8, and then multiplied by C. And that will be the equation we'll use with this color sensor. So what we're going to do is we're actually going to connect from the color sensor to where it says B. And we're going to change A to 35. We're going to take a closer look at the math block. Let us see how we get the value for A. So if we were to connect the robot with the color sensor on to the computer while using the Lego Mindstorm software, we should see that our color sensor comes up in this little area in the Mindstorm software, and it shows us the data that the color sensor is reading also. Now, if we were to put the robot and the color sensor facing a black line, like seen over here, we should see that the data it's getting, or the light intensity reading, is very low. It's around 9 or 10%. This means that very little light is getting reflected off of the black color on the map, and little light is being seen by the color sensor. Now, if we were to take the robot with the color sensor and face it on a white part of the map, as seen over here, we should see that the data that the color sensor is picking up is relatively high. The light intensity reading is anywhere around 97 to 100%, or it's just very high towards the 100% area. This means that a lot of light is being reflected back into the color sensor from the white surface compared to like the black surface. When we place the color sensor in between the black surface and the white surface, the light intensity reading we will receive is around 35 to 38%, or in between that range. This is what we consider the ideal location or the ideal position because we want the robot to follow this line. This is how we determine the value of 35 for A. So we are going to connect for our B value our color sensor into where B is. And this is supposed to basically have B represent the measurement of data from the color sensor. The next value we'll be looking at in the mathematics block will be the value of C. So currently we have it at 0 right now, but for our program, we're going to change it to -3. And this is because we want our robot to have more smoother turns as it's following the line. For your robot, you can set it as -3 right now, but you can also test a few different values like -1 or -2 for whichever one your robot does better with. So the next thing we're going to do is we're going to go get a move steering block from the green section. So it should be the third block in, and you're going to add it after the mathematics block. Now what we're going to do is we're going to change the move steering block and adjust it. So we're going to click on where it says on for rotations, and we're going to just choose on. So now we have a more simplified version of the move steering block. So what we're going to do is we're going to take the output from the mathematics block, which is this equal sign, and we're going to attach it to where the arrow is in the move steering block. We're also going to change the speed to 10. This is because we want our robot to be slow enough that it's actually able to see the line. If your robot is too fast, it might not be able to correctly follow the line as accurate as if it was slower. Let's look at our code that we have right now. We have that the robot is moving forward enough distance that it gets outside of the base and towards the thick black line. Then we have our loop. And inside our loop that goes on for 38 seconds, we have our color sensor that is going to be picking up data or the light that gets reflected off of certain colors from the map. Now say that we had the light getting reflected, that value of being 50. Okay, so then 50 becomes the value of B. So according to our equation, we have A minus B. So we're going to have our ideal position, which is 35, minus 50, which is -15. And in our equation, we have that times C. And C is the value of -3. So we have -15 times -3, which is going to be positive 45. This value will then get outputted into our move steering block that we have next. So that way the robot will turn to the right. We can see this as if I had put in 45 in here, the robot would be turning right anyways. So say we had a different value coming up from the color sensor. Say we had 15. So then 15 becomes the value of B, and we have, according to our equation, 35 minus 15, which is going to be 20. Then we have that value times C, which is -3, so 20 times -3 is -60. That value will then get outputted to our move steering. So if we then saw what that would be, we could see that if we put -60 in here, the robot would be turning to the left. In this session, we're going to learn how to code an ultrasonic sensor using the Lego Mindstorm EV3 software. The first block we're going to attach is the loop block, which we're going to find in the orange section called flow control, and it's the middle block. You're going to click, hold, drag, and attach this to the starting block. Now say we wanted to use an ultrasonic sensor to detect the basketball mission. What we can do is we can change the unlimited to time and have our ultrasonic sensor set for, we'll say, 20 seconds, and this is a guess. You might have to change that depending on your starting on your base, but we can have the loop and ultrasonic sensor working for 20 seconds. The next block we'll be putting in is the move steering block. So you're going to go to action or green, and you're going to get the move steering block and attach it inside the loop. Now we want our robot to continue to drive forward no matter whether the ultrasonic sensor sees it or not. So what we're going to do is we're going to change the on for rotation and we're going to just choose on. This is a lot more simplified version of a move steering block, and it'll just keep on moving forward no matter if our ultrasonic sensor sees anything or not. So then we're going to add the ultrasonic sensor. So what we're actually going to do is we're going to go into flow control and we're going to choose the weight block and we're going to add it after the move steering block. Now, what we're going to do is we're going to adjust the weight block and we're going to click where it says time and we're going to choose ultrasonic sensor, go to compare, and then distance in centimeters. What this is basically saying right now is saying, okay, I want you to continue to drive forward and have the ultrasonic sensor on until you see something in front of you. But if you notice, we have 50 centimeters right here, and that's a pretty large distance. So what we're going to do is we're going to change 50 to 15. So this is a pretty reasonable distance. So what our code is saying right now is we're saying, hey, we want the robot to drive forward and keep the ultrasonic sensor on until it sees an object less than 15 centimeters in front of it. However, the 15 centimeters can change depending on which mission you're doing and how much distance you want in between your robot and the object that's going to be in front of it. Now, after the ultrasonic sensor has seen an object in front of it, we actually have to code what the robot is going to do after it sees an object. So what we can do is we can go to move steering, and then say we wanted the robot to stop and then activate a small motor. What we can do is we can go to move steering, get the move steering block, and attach it after the ultrasonic sensor. We're going to click here and choose off. So this will make the robot stop. And then what we're going to do is we're going to get our small motor or medium motor and attach it right afterwards. So after the robot stops, in our code, we have a medium motor coded right now. This is for, say, if you had an attachment onto your robot that was needed to complete the mission. What this code does right now is after the robot sees the object or the mission in front of you, it'll stop and then it'll activate your medium motor. This will activate whatever attachment you have, and that might be able to complete the mission that's in front of you.